Hi all, today we'll be starting with this question, daily LeetCode question, that is find the last and first position of an element within the given sorted array. So in this question, as you can see, we are given an element value and we need to find whether that is present. If that is present, then we need to return the first and last position of that element within that array. So the simple approach is like we can just traverse the array, means there are two approaches. So like one will be of big O of n, means but with that would require traversal twice. So like you can see, we can just traverse the whole array twice. So first we will be starting at the index uh, from the index 0 and checking like whether 8 is present or not at that index. If that is present, we can store it in a variable, two variables, that is index 1 and index 2. So ind1 and ind2. So these variables will be used for storing the indices of the first and last occurrences. So this can give us the answer in big O of n. So but there is an catch here. So we can apply binary search as we are given the array is sorted. So we can always apply binary search. So how we'll be applying it? So there are two ways. Either we can apply STL approach or just directly the basic fundamental or binary search. So we'll be trying to implement the binary search. So once I could, I will be showing like how it will work and do dry run of it so that it can be more easy for you to understand. Okay, let's proceed to the coding part. So here n is signifies the size of the array. We'll be taking two pointer, low and high. So while low is less than equals to high, till then we need to do this until we find. And the basic template for binary searches, like we do need to compute a mid element. After computing in the mid element, we cut down the half part of the array. So what happens in binary search, we just look for the target. So this is the size of array of 6. So 0 1 2 3 4 5. So 5 is the last index. So 0 plus 5 is 5, and by 2 is 2.5, but we do take the integer value. So 0 1 2, at index 2 7 is present, so this 7 is less than 8. So we know, like if we move right side to this, so we always will be getting 8. So we will be updating our low index to the mid plus 1, and this will be the approach which we will be following. So let it code high minus low by 2. So we are following the this thing because in order to avoid the overflow. So this is done in order to avoid the overflow. So let's say if indexes are quite long, so this can might overflow if we add them both together. So high plus low, that can give us the overflow errors. In order to avoid, we are writing this thing. So then checking if we are getting, if the value of the mid element is equal to the target. So at that point we know, okay, we got that element, but we don't know like whether it is the first occurrence or the last occurrence. So means that there can be case, let's say if there is one more 8 in the middle and we stopped at there. So we don't know like whether we are at the first occurrence or the last occurrence. So for that, what we will be using, we will be using an two index value. So index 1 and index 2 is equals to minus 1, let's say at the initial position, because let's say if they are not found within the array, so that case will be already handled. So initializing them to index 1 and index 2 is minus 1. And for the first part, so let's say we are moving, we are trying to find the first occurrence. So we are trying to find the first occurrence, means that high. So we should not stop after finding the element. We should be moving to the first element, first occurrence of the element. So that high should always be decremented to the mid minus 1 after finding the element. So what will happen? So let's say we got the element, we will store the index of this element. Index 1 equals to mid. This will be storing. So let's say if that element occurred, means something like this, it will be. So whenever we are at this index, so by chance, if we come here, we will move to the m minus 1 element. So we are at, we will be just storing the index of the element and moving the high part to the mid minus 1, because we got that element, but we are not sure whether it is the first occurrence or not. But in order to get the first occurrence, that high should be moved to the mid minus 1 element, and the start should be always, means low should be always at the starting point. And similarly, let's say if, else if nums of mid is less than the target, means if the element which we want is less than the element which we got, then just increment the mid plus 1. Low is equals to mid plus 1. At any case, high is equals to mid minus 1. So yeah, so this is the thing. The same, this will give us the first occurrence of the element, because we are updating the first occurrence and then moving the high part, and again updating the elements. Low is equals to 0 comma high is equals to n minus 1. Then the same algorithm will work for finding the last occurrence as well, but just a small change in the code will be, instead of storing the index 1 element, we will be storing the index 2 element, and this we will be moving forward. So low will be changed to mid plus 1. So this is the thing. So just the little bit change modification to the code, and this will give us the last occurrence. As you saw, our template remains the same: low, high, computing mid, target is same, then just storing the value of that element, and increment or decrement based on our requirement. This is the basic logic, and let's see whether this works or not. Yeah, so this is working fine. So let's say this will work for the negative elements or empty elements as well. So yeah, this worked fine, and yeah, so this is the solution. Hope you hope you got the solution. See you in the next video. Thank you.